number 18 asks us to find two explicit functions by solving the equation for y, and then to sketch the graph and label the parts that correspond to which parts of the graph, and then differentiate the explicit functions, and then differentiate the original equation implicitly to show that it's the same. Woo! Lots of stuff to do here. The very first step is this is in general conic form. I would like to simplify it, and I would like to write it so that it shows its transformations. So the first thing that I'm going to do is get the constant term to the right side and then group the x's. So x squared minus 4x, and then there will be a new c that I add there, plus y squared plus 6y. There's going to be another number I'm going to add there to complete the square, and then negative 9 is on this side. Okay, negative 4 divided by 2 is negative 2, squared is 4. That's what goes here. If you add 4 on the left side, you got to add 4 on the right side. 6 divided by 2 is 3, 3 squared is 9, add 9. It is a perfect square trinomial, and it factors to be x minus 2 squared, plus this one as well is perfect square trinomial. Y plus 3 squared is equal to negative 9 plus 9 is 0. All right, is equal to 4. Find two explicit functions by solving the equation for y. Okay, so now we're going to solve the equation for y. I'm going to start by subtracting this quantity. Y plus 3 squared equals 4 minus the quantity x minus 2 squared. I know that when I expand this, that I can combine some like terms and possibly break this down a little bit before square rooting. If I can simplify it anymore, that would be nice. So that's what I'm going to do. 4 minus this trinomial, so x squared minus 4x plus 4. You know what that looks like. It's right up here. And then minus, so 4 minus x squared plus 4x minus 4. Okay, so we do get a little bit of a simpler version. Y plus 3 quantity squared is equal to negative x squared plus 4x. Many times when I look up an answer to something, they really don't like if one of the terms is positive and one of them is negative, even though this is technically descending order, right? This is the larger exponent and this is the smaller one. They really don't like that negative hanging out in the front, and I understand because sometimes you can forget about it, but it does feel a little weird because we've been writing in descending order. You're not going to be counted off for the order that you write it, but if you're wondering why I'm going to write 4x minus x squared, that's all the answers were written, and anytime there's a minus, they usually like to put it in between. Unless there's a minus on both terms, then they'll write it in descending order. Just another trick. Square rooting both sides, and we get y plus 3 is equal to plus or minus the square root of 4x minus x squared. Our last step is to subtract 3 on both sides. Y is equal to negative 3 plus or minus the square root 4x minus x squared. After we completed the square, maybe you were able to recognize, hopefully, that this is a circle, and it is at the center is 2 comma negative 3, and the radius is the square root of this, so the radius is 2. So when we graph that circle, your center is at 2, negative 3, and then your radius is 2 units. So you go 2 units up from the center, 2 to the left, 2 to the right, and 2 down. So you can complete your circle. Now this turns into two separate equations. Negative 3 plus square root 4x minus x squared. Restricting the domain to between 0 and 4, The other equation is the negative version, so negative 3 minus root 4x minus x squared. Again, the x's must be between 4 and 0. This one is the upper half of that circle, and this is the lower half of that circle. So what we've done here is complete part B, which asked us to sketch the graph and label the parts given by the corresponding explicit function. So you can see which explicit function matches with which part of the graph. Our next step is to explicitly differentiate this equation and this equation. First, I will rewrite the radical as a fractional exponent and then derive both sides. So y prime is equal to the derivative of a constant is 0, and the derivative of this requires the chain rule, which is the derivative of the outside times the inside times the derivative of this inside. Pop down negative 2x plus 4. If you're having trouble visualizing that, it looks like this. Power rule would be negative 2x plus 4 times 1 is 4. Let's simplify. Y prime is equal to, you have 0 plus, so that doesn't change anything. And then you have this whole product. Some of it belongs on the top, some of it belongs on the bottom. This belongs in the numerator, this belongs in the denominator, this little 2 belongs in the denominator. So I have 4 minus 2x, just to go along with the writing the minus sign in the middle, and over 2 times this quantity, 4x minus x squared, to the positive 1/2. Hey, there is a 2 in each term in the numerator and in the denominator, so let's factor out a 2. 2 minus x over 2 times, I'll write this now as a radical because it's just a square root. If it were, to the 2/3, then we'd probably just keep it written as a fractional exponent, but usually we write them as a radical if the numerator is 1. 2 over 2 is equal to 1. Y prime equals 2 minus x over the square root 4x minus x squared. All right, so this right here is the explicit derivative of the top semicircle. Let's do the bottom semicircle. The only difference here is this sign in between, right? So I believe what is going to be changed would be the sign of this derivative right here, but I'm still going to go through the steps just to make sure I get it right. The derivative of negative 3 is 0. This can be written as 4x minus x squared to the 1/2. So we'll use the chain rule, negative 1/2 times the inside times the derivative of the inside. We already did that. That was negative 2x plus 4. Y prime is going to be equal to a fraction. This goes in the numerator, this is in the denominator, and this is in the denominator. I'll write this now as 4 minus 2x. Don't forget, this whole thing will be negative. So negative to either the numerator or the denominator, but not both, over 2 times root 4x minus x squared. We can factor out a 2 out of the top and reduce it with this. I'm going to do it the lazy way this time since we already did it. So divide this by 2, divide this by 2, divide this by 2. Negative 2 minus x over 2 divided by 2 is 1, in case you were wondering, because apparently I was. We have explicitly differentiated the bottom half of the circle. Now they've asked us to find dy dx of the original equation implicitly to show that it is equivalent to these two explicit derivatives that we've already found. Here is the original equation, and we will derive both sides with respect to x to find dy dx implicitly. The derivative of x squared, variables agree, so that's easy, 2x, plus the derivative of y squared. I feel like we've done this quite a few times by now. Remember, when you're deriving y squared with respect to x, it's 2y dy dx. Minus the derivative of 4x is just 4 times the derivative of x, which is 1, so we're left with minus 4, plus the derivative of 6y is 6 times the derivative of y. That is dy dx. Plus the derivative of 9, the derivative of constant is 0, the derivative of a constant is 0. Group your dy dx terms, so these will go on. I'll keep them on the left side of the equation, and I'll move these things to the right side. We have 2y dy dx plus 6 dy dx, and then inverse operations, positive 4 on the right side and negative 2x on the right side. Factor out a dy dx, 2y plus 6 equals 4 minus 2x. Hey, I noticed that 2 goes into all of the terms that I have here, so I'm going to factor out in this step just to save myself a little time. This is 2 minus x. When we divide by, I'm going to factor this one out too, if you don't mind. That is 2 times y plus 3, so 2 times y plus 3. 2 over 2 is 1, dy dx is 2 minus x over y plus 3. Our implicit derivative right here is supposed to be the same as our two explicit derivatives right here. But it doesn't quite look the same. So we have to look at the relationships. Okay, these only have x's in them, right? They're written explicitly. Can we write this explicitly as just x's so that we can compare and make sure that these are equivalent? Let's look at the difference between our explicit and our implicit forms. The derivative, the denominator of the explicit form is this weird looking root, and the denominator of the implicit form is y plus 3. Do we have any sort of relationship between these that was previously given to us or previously found by us that can help us to compare and make sure these are equivalent? Yes, we do! Y plus 3 is equal to plus or minus the square root of 4x minus x squared. It's right there. To write this explicitly, dy dx is equal to 2 minus x over plus or minus the square root 4x minus x squared, because that is equivalent to y plus 3, which gives you two equations. And here you can see we have the positive version and the positive version, and then this negative that is in front of the fraction could actually be written in front of the root, which covers our other possibility, our plus or minus root 4x minus x squared is equivalent to y plus 3. So we have just proven that our implicit differentiation is equivalent to our explicit differentiations. And I don't know how you felt about it, but I definitely felt like implicit differentiation was much more efficient than explicit in this case.